Hi friends, this video is on motion, speed and velocity, part 4 out of 14. This video is brought to you by COACHINGCARES.IN, designing future with smart education. Topics to be covered in this chapter are speed and velocity, slope of speed and slope of velocity. Let us start with the speed and velocity introduction. So what is the speed? Speed is nothing but it's a rate at which an object covers the distance. Distance you understand clearly. Distance is basically path length or the trajectory that object covers in a given time period. This is one. This is the scalar quantity. This is having only magnitude. There is no direction in the speed. So this is scalar quantity, and we can say it is a path length per unit time. At the same time, velocity is very much similar. The difference of velocity and the speed is like the velocity is having the magnitude and the direction also with this. Rate at which object changes its position is called the velocity. Whereas the speed, there was rate at which the object covers the distance. So this position and distance, this is the important term while defining both the quantities. Here, direction involves, okay, but here only magnitude is there. This is the major difference, or we can say the velocity is the speed with the direction. It's a vector quantity because direction is involved in this, and this is the displacement basically with respect to the time. So these both the quantities we will study in depth in the next slide. With some examples, we'll see. You just have a look of both the plotted graphs. For this one is the distance and time graph, and this one is the position and time graph. Distance and time graph, this is the speed basically. Distance, change in distance with respect to the time is the speed, and here this change in the position of the object with respect to the time, this is called velocity. So here speed comes into picture in this graph. This speed comes into picture, and here velocity comes into picture. So here you just have a look of this graph, distance time graph, and just try to understand in depth. You just see there are three plotted graphs are there. One is in green line, one other one is in blue line, and the third one is in the red line. So this green line graph, you can see this is a steady graph, and it is going very gradually, steadily in a straight line. This distance is changing with respect to the time. This distance is changing more. So this is fast. You can say this graph is fast, steady speed it indicates. Another one, this blue line graph, it is in the starting is started, the speed is low, then while reaching to the final position, the speed is getting little higher because at the starting point, you can see in this region, this distance is, it is changing a lot with respect to the time. So this is getting a faster speed. Now we'll see the graph, red color graph. You'll visualize this straight line, steady line, this slope line. This is called a steady. It is indicating the steady speed. And if you'll see the straight line, horizontal line from this point to this point, this graph line is horizontal, line and it is not changing. I mean, distance is not getting changed in this region. You will notice the distance is same. Some value x here, the distance. So this is same. So this region is known like stationary region of the object, or object we can say at rest. After that, from this point to this point, it is coming back to the rest position or initial position of the object. So we can say this plotted line like returning to the starting position of the object where it started the journey. So like this, we can understand different stages of plotted graph uh, in different scenario. I mean, different values of distance, different values of time. We can define the graph, plotted graph, and we can define rather the motion of that object in different conditions. Like this, the same way, you just visualize this velocity graph or position time graph. We can say we call it position time graph. The position, x-axis we taken the time, and the y-axis we taken up the position in meters, time is in second. You just have a look of this plotted graph. This is being drawn by joining these points. You just study this point is after 1 second reaching the 10 meters, of 2 seconds it is reaching 20 meters, after 3 seconds this object is reaching at 30 meters. Like this, when we are joining all the points, we can plot this one straight line graph, which is known steady velocity. It is the slope of this is called the velocity of the object. So both the terms we can define in a graphical form in that way, and we can calculate, I mean, different parameters in the motion while solving the problems and the numericals. So these plotted graphs will play a very important role, and these graphs are very important to understand basically in depth and details the velocity, position, and distance and all while studying the motion. So further we'll study the slope of both the quantities. So next slide. Let us go on the next slide. We'll study in detail the distance time graph. So distance time graph we can study a little bit in depth now. Just assume this boy. This boy is on bicycle starting its journey from its home. This is the home, okay, and it is going to the shop. This is the shop. This boy is starting its journey from here, and it is going to the shop, and again taking by U-turn, it is going back to the initial position to the home. You can visualize this distance. Suppose this distance is 20 meters, you can say. So we know going back it will cover the same distance, 20 meters. So you just assume this is the starting initial position of the boy. So from here it is going this shop going back to the final position. So distance covered from this point to this point is 20 meters. So we can say the distance time graph, we can make the distance and time with respect to the time. We can plot one graph. So total this change in the distance with respect to the time is the speed of this ball. So like this we can plot the graph and we can visualize it, we can understand in a better way. So in the same way, now we'll study a little bit more in depth about the speed or about the distance time graph, what we can get from the distance time graph. Distance time graph, we can get the speed. So this is very important. Just focus on this. Uh, from the distance time graph, the important parameter we can calculate the speed, which will play very important role while solving the problems in numerical problems from the distance time graph. And many problems comes in exams also from distance time graph. You have to calculate the speed. So what is speed? Basically the slope of distance time graph is called the speed. So here you can visualize, suppose this is the starting position, and this position goes to like this straight line. This is the, this is the plotted graph. In this direction you can take time, and in the vertical direction you can take distance. Or along y-axis, this is y-axis and this is x-axis. So we are getting this graph. We are assuming this graph. Suppose this is the initial position and this is the suppose final position we are assuming. At the final position, after 2 seconds, suppose we are taking it in 2 seconds, and this is distance is coming okay in meters. So okay, this after 2 seconds here it is moving 2 meters. So that's why this graph is a straight line. It shows the speed is steady, and the slope of this graph, I mean this is, suppose we complete one triangle here, and suppose this is the angle theta. So what will be the slope of this this journey? This is A, I assume this is A, this is B, this is C. So slope of distance time graph, it will be equal to what? Speed. So slope of this will be tan theta, which will be equal to perpendicular to hypotenuse, as you know in the trigonometry. So this will be equal to what? BC perpendicular to base. So this will be equal to BC, this is perpendicular, and base is AC. So this will be equal to, again, BC is what? BC is this one, 2. This is on y-axis, distance showing the on y-axis. So this is 2 divided by AC. AC is nothing but, on the x-axis, it is showing the time, which is 2. It will become 1. So the slope of this is the speed. So this is 1 meter per second. So slope is equal to tan theta is equal to 1 meter per second. So this is the important outcome of this graph, which is the slope, which comes in the form of speed. We call it is a speed. So this is important outcome of this graph. So it will be very important while solving the problems and numericals in this chapter. So let us again study the next position time graph. So in position time graph, again assuming the same example, this boy is again with the bicycle starting journey from the home, going to the shop, going back again to the home. So what will be, we will study, I mean, change in position per unit time is velocity. So change in position is what? Suppose this is 20 meter, this is again 20 meter. So change in position per unit time, So change in position, this is your initial position, and this is again your final position. So change in position is equal to final minus initial position, which will be equal to 0. And this change in position is what? This is called velocity. So velocity will be equal to 0. So while studying this, example, so velocity of this will be equal to 0, because we are considering change in position here, not distance. So this is an important difference to understand between position time graph and uh, distance time graph. So here if you take the on x-axis is time, and here if you take the position, then graph line will come something like that. So this is the graph line, and this graph line slope of this, again we'll study in the further slide, slope of this graph line will be the velocity of the boy. So further we'll study how we'll calculate the slope, how we'll calculate the velocity from the position time graph. So now we'll study the slope of position time graph. Okay, let us assume, okay, this is time we have taken on x-axis. This is, we have taken distance along y-axis. I just plot one graph. Starting journey is this one, and it goes to up to this point. This is point B, this is point A. So we can say after 2 seconds, I just complete it like this. After 2 seconds, this object is reaching 2 meter or 2 unit distance. This is steady graph. So slope of this graph will be, we'll calculate the slope of this graph will be the velocity of this one. Suppose this is theta1. And after this, it is going back up to this position. So we'll study, I mean, the slope of position. Slope of position is what? Velocity. Slope of position time graph is the velocity, right? So slope of this whole journey, starting from here, A, B, okay, this is the last point, C. You just calculate, you just visualize uh, the slope of this graph will be, suppose this is slope 1 and this is slope 2 of this whole journey. So total slope or slope of this graph will be slope 1 plus slope 2. So slope 1 will be equal to tan theta 1. Okay. This will be equal to what? Suppose this is 1 point D. So this will be 2 by 2. I mean B D divided by A D. So this will be equal to 1. Or we can say, suppose I take the time in second, I take this distance in meter. So this will be 1 meter per second. In the same way, I will calculate slope 2. slope 2 will be equal to tan theta 2. Here we'll take minus sign, so this will be minus 2 by 2. So this will become minus 1 meter per second. You just have a look of that, because this theta, we have taken this theta angle, theta 2 angle. This is the negative anti-clockwise angle. So we have taken the minus sign. So now we'll calculate total slope of the whole journey to calculate the total velocity of this one. I mean, total slope will be equal to slope 1 plus slope 2, which will be equal to, we are putting the values 1, so this is equal to 1 minus 1, which is equal to 0. So this is the velocity. So total slope is velocity basically. This slope is basically velocity. Okay, so we can calculate velocity by from the position time graph very easily. Very important to understand it to solve the problems and numericals coming in this chapter. So I hope you are now able to understand all the concept clearly. So this is all in this lesson. Okay. So thank you very much for visiting COACHINGCARES.in, designing future by smart education. So you can visit COACHINGCARES.in, watch free educational video, get best quality study materials there, and study from best tutors and mentors. Thank you very much again.